What is pressure cooker? Pressure cooker are well known for using steam pressure for rapidly cooked food. Steam is produced as the water within the sealed pot heats up, raising the temperature and internal pressure and also accelerating the cooking process. In result, it is better nutrient and flavor preservation than traditional technique. A modern pressure cooker has multiple essential parts, including a sturdy pot or body made usually from aluminium or stainless steel, a safety valve for added security, an airtight sealed gasket, a pressure indicator, a tightly sealing lid with a locking mechanism, a pressure regulator or valve to control internal pressure, and heat-resistant handles. Many versions also offers digital controls and pre-programmed settings, which increase convenience and efficiency for customers who are already accustomed with this function. In 1679, by French scientist Denis Papin, the steam digester as early version of the current pressure cooker was invented. Next, we move to the fishbone diagrams. The combination of FMEA and fishbone diagram provides a thorough approach to identify and address the potential failure modes. The fishbone diagram has been chosen in brainstorming session to visualize root causes, which has been categorized into people, methods, equipment, material, environment, and mechanical parts of the product. As we can see in the next slide, for example, people, the failure mode, which the factor is user error. It can be the effect of scald, burn the skin with a boiling or steam, severe burns. And next is methods, incorrect operation procedures, as the effect is overpressure, overcook, or bursting. And the third one is equipment. For the failure mode is malfunction component, which result in pressure release valve stuck, cooker explosion. And the next one is materials. Materials is poor material quality, which as a result is crack, seal ring, material fatigue. And the fifth one is structural failure for mechanical, as the effect is pressure cooker crack and unstable pressure. And the last one is environment. The factor might be external factors affecting performance, as the effect is influence pressure cooker efficiency and wasted ingredients. That's all for the potential failure modes in fishbone diagram of pressure cooker.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Al-Hadi Nasrullah bin Mustafa Kamal with number matric B092110018. Today I will explain about FMEA, which is a failure mode and analysis table. The failure mode and effects analysis, which is FMEA for the pressure cooker, is a detailed assessment aimed to identify potential failure modes and mitigating the associated risk to enhance the device's safety and reliability. The analysis begins by defining the process function such as pressure regulation and pressure monitoring, and identify potential failure modes like the pressure relief valve failing to open or incorrect pressure readings. Each failure mode is assessed for its potential effects such as overpressure, potential explosion, and burns, and it's rated for severity on a scale from 1 to 10, with a higher number indicating more critical effects. The potential causes or mechanism of failure, such as spring fatigue, corrosion, or calibration error, are then identified. Current process controls like visual inspection and calibration verification are noted, and the likelihood of occurrence and detection of each failure is rate. This rating are used to calculate the risk priority number, which is RPN, which helps prioritize the failure modes that need the most attention. Recommended actions such as a design review and enhanced calibration procedure are proposed to reduce the risk. For example, the pressure relief valve issue with an initial RPN of 150 is addressed to material optimization and corrosion prevention. reduce its RPM to 48 after implementation. Similarly, the pressure monitoring issue RPM is reduced from 48 to 30 by enhancing calibration procedure. The FMEA table highlight critical and major potential failure modes, their causes and effects, and the systematic approach ensure that the most significant risks are prioritized and mitigated effectively. In a summary, the FMEA process identify key risks associated with pressure cooker operation and implement targeted action to improve overall safety and reliability, ensuring potential issue are addressed systematically to reduce the risk of failure and enhance user safety.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nilana Amira bint Ahmad Fairuz. My metric number is B092110092. Today I am going to explain about the Pareto chart that we obtained from the FMEA table. So the orange line indicates the cumulative percentage of the issues, which enables 20% of the issues are causing 80% of the problems, and where the effort should be focused to achieve the greatest improvement. So in this case, approximately 80% of the issues have been resolved by the time it reached to cooking time control, as indicated by the dash line. And in the end, the most critical issues to address are pressure regulation, sealing, ventilation, and locking, as they constitute most of the problems.
For the calculation of risk priority number for each failure mode and Pareto failure mode, analysis focus on the calculation of the risk priority number, which is RPN, for each failure mode, and the identification of critical failure mode using Pareto analysis. From the Pareto analysis, we identified that pressure regulation, sealing, and ventilation are the top 3 most frequent issue, with frequency of 150, 96, and 72 respectively, accounting for significant portion of the problems. The analysis further categorized other issues such as locking operation, leak locking mechanism, and indicator functionality with their respective frequency and ranking. Based on stability, pressure monitoring, heating, handle functionality, and cooking time control share similar frequency, emphasizing their relative importance. Overheating protection and structural integrity with a lower frequency represent the least common issue. This detailed breakdown highlights the prioritization needed to address the most critical components impacting system performance and reliability.
To conclude this video presentation is that the FMEA for the pressure cooker has highlighted that 20% of the issues are responsible for 80% of the problems, which are suggesting that efforts should be concentrated on these key areas to achieve the greatest improvement. So the cumulative percentage of resolved issues shows significant progress, with approximately 80% of the issues resolved by the time cooking time control is addressed, as indicated by the dash line. To further enhance performance, the focus should be placed on addressing the most critical issues, which are pressure regulation, sealing, ventilation, and locking, as they constitute the majority of the remaining problems. In the end, by prioritizing improvements in these areas, overall systems efficiency and effectiveness can be substantially increased. Thank you.